infinity to negative 10, yes, increasing definitely. From negative 10.5 to negative infinity, yes, indeed. From positive infinity to 0, yes, that's true. From 0 to negative 1.5, that's true. From a negative 1.5 to negative 1.3, yes, it's going up. From negative 4.3 to 0, yes, it's going up. And from 0 to infinity, yes, it's going up. Everything checks. Now this is the ugly part. So let's move on to the second derivative, which is not friendly. I have to differentiate this, which is horrible, but let's do it. The denominator is squared. The top function prime, 2x plus 6, times the denominator, minus the top, times the denominator prime, careful, 2x plus 3 to 2 minus 1 times the inner function prime. Do not cross out anything. But yes, I will factor out x plus 3, and I can also factor out a 2 from these two. So 2x plus 3 will come out from these two top terms. Never multiply, always factor out and simplify. Okay, so let's see what is left. I took out a 2, so an x plus 3 is left. And another x plus 3 is left as well. These two are out, so I need to distribute the negative sign. Negative x squared minus 6x and minus 4. Not too bad. Now I can simplify. I have 2. I have to square this. We did this a long time ago. Over x plus 3 to the third. Luckily, these two go away. Oh, luckily, these two go away. And 9 minus 4 is 5. 5 times 2 is 10. Never 0. Because the numerator is never 0. Can never be 0. But careful with the sign. Because the sign of this expression is x plus 3 squared times x plus 3. This is always positive, but this will give the sign. So to the left of negative 3 is negative, to the right is positive. So to the left of negative 3 is negative, to the right is positive. So not holding water, it does. So we know that this is, you already told me on the previous problem, local max. You already told me that this is the x-intercept, and this is another x-intercept. No, this is the y-intercept, and this is the local min. Okay. Finally, let's determine the slant asymptote and graph the function. So here's how we determine the slant asymptote. We divide. So that's my page 5. Using long division, or in this case, synthetic division. Which one you prefer? This always works unless the denominator is just one term. This one is limited. So the function is x squared minus 4 over x plus 3. Which one would you like? The synthetic or the long division?
I usually use the synthetic if I'm able to.
Okay, very good. So remember the numerator has coefficient 1. The coefficient of x, it does not exist. And the free term is negative 4. What goes in the box?
Negative 3.
Excellent, very good. We bring down 1, we multiply by negative 3, and we write the answer above the line. We add these two, we multiply, negative 3 times negative 3 is 9, and we put the number above the line, and now we just add, and we box the last number in, which is 5. So x squared minus 4 over x plus 3 can be replaced by x minus 3 plus 5, the remainder, over the divisor. This y equals x minus 3, just the quotient, because this is the remainder. And this is the divisor. Just the quotient is the slant asymptote. That's the only thing that does not fit in the table. But we have to keep in mind that it has to be graphed. Okay, so let's graph this function. When we graph functions with asymptotes, we have to start by graphing the asymptotes. This function has two asymptotes. One is x equals negative 3. And the other one, when x is 0, y is negative 3. And when y is 0, x is 3. I would like to go to the next page because I don't have enough room. So x equals negative 3. For y equals x minus 3, I have to find 2 points. So when x is 0, y is negative 3. When y is 0, x is 3. So 3 comma 0, 0 comma negative 3. So 3 comma 0, 0 comma negative 3. This is y equals x minus 3, the slant asymptote. Only now I will read my table and only my table. And I don't care for anything else. Okay, I have to plot some points. And here are the points we need to plot. Negative 5.2, negative 10. 3, 4, 5. 3, 4, 5, 6, 7, 8, 9, 10. Negative 10.5. Okay. Somewhere here. Okay, so I can already graph this piece. It's coming from the slant asymptote, going to a maximum, coming back to the vertical asymptote. No problem. From the slant asymptote to a maximum, approaching the other asymptote. Now, this side, I have negative 2 comma 0. I have negative 0.8 comma negative 1.5. I have 0 comma negative 4.3. This is kind of hard to present. I have 2 comma 0. So from infinity, crossing the x-axis, coming to a local minimum, crossing the y-axis, crossing the x-axis again, going towards infinity. This is the graph that you chose, a very good graph. Thank you very much. Here it is. Yes, you should always, after you present the work, you should always do this. Go to y equals. The calculator will not present the slant asymptote. You have to put it in as x minus 3. Let's use zoom 6 for now, and we'll see in a moment. Here it is. Okay. So this is the top part. I'm going to change the viewing window so you can see the bottom part. The y minimum should go to, let's say, negative 20. And let's try again. Here it is. Aha. And here's the vertical asymptote at -3. Here's the local maximum. Here's the local minimum that we determined by hand. And here's the vertical asymptote. Again, the calculator will not put the slant. You have to put it in yourselves. Okay. Any questions? Okay. Do we have time to quickly look at a word problem so we can move on? Where is it? So let's look at a word problem. Okay, let's look at the total cost and revenue. So the total cost and revenue in dollars from producing, so that's 59, is what is it? Okay, C of X equals 5,000 plus 600X, and the revenue is -1/2 X squared plus 1,000X. Find the total profit function. We've done this before. So the profit function is revenue minus cost. I copy the revenue, -1/2 X squared plus 1,000X. Don't forget this is minus for all terms in here. So minus 5,000 and minus 600X. So simplified into -1/2 X squared plus 400X minus 5,000. This is the profit function. Any questions so far? Are you with me? Okay, so let's continue. Part B, find the average profit, which is P of X divided by X. It's given, so let's find this. Okay, fine, no worries. So then P of X divided by X, -1.2 X squared divided by X is -1.2 X. 400X divided by X is just 400. And minus, I didn't mean to write the, I'll erase it in a minute, 5,000 over X. Good, so we found the average profit. Let's see what they want us to determine with this. Good, that was part B. Find a slant asymptote for the graph of this. That's all I wanted, and we don't need to graph it. So this is already done. Because the denominator was one term, this is the remainder, this is the divisor, and this is the quotient. This is y equals -1/2 X plus 400, which is the slant asymptote of the graph. Okay? Any questions on this? Any questions? Anyone? Is anyone with me? Okay, I would like to continue with 2.4, finding the absolute max min on a closed interval. Finding absolute, also called global, max min or min on a closed interval. So this is much easier than what we had. We are not looking at the entire domain. They are telling us what the domain is. So let's move on to page 242. So 242, and let's choose, where's my keyboard? 242, enter. Okay, find the absolute extrema, which is absolute max min, of each function over the indicated interval. Okay, so we know how to determine max min for such a function, right? This is quadratic. It doesn't have max min. I mean, this should not even be here. A quadratic function has a minimum or a maximum, but it will only have one or the other. So let's move on and look at something that is given on a closed interval, like something like this. This is the whole purpose of this section, to discuss max-min on a closed interval. So let's choose a function.
70.
70. Let's start with 70. Good. So 70 is f of x equals 2x to the fourth minus x, and the given interval is negative 1, 1. Perfect example. Let's start. So if we're only asked about max-min, there is no need to find the second derivative. We could use the second derivative test, but there is no need. So first, let's find the first derivative. Can anyone give us the derivative of this? So
8x to the third power minus 1.
Excellent. Very good. So now all I need to do is f prime and f of x. There's no question about domain. This is it. Negative 1 to 1. I have to set this equal to 0 and find critical numbers. So 8x cubed minus 1 equals 0. And this is basically the only option we have is 8x to the, although there are 3 solutions, 2 of them will be imaginary, so only 1 is real. 8x cubed is 1, move 1 to the other side, divide by 8. And when we take the cube root, we obtain only one real solution, 1/2. Is 1/2 in this given domain? Yes, it is. So I'm going to put 1/2 and 0. Now let's study the sign of the derivative. This is the derivative, so let's plug in negative 1. I just need the sign. I don't need the number. Any number to the left of 1/2. You can plug in 0. That's the easiest. 0 is between negative 1 and 1/2. So when you plug in 0, what is the sign of this expression?
Negative.
Very good. On the other side, let's plug in 1. 8 minus 1, positive. I need to determine these 3 numbers. So I plug in the original function and plug in negative 1, 1/2, and 1. I plug that in the graphing calculator, put it in. So I'm sharing. Here's my calculator. So go to y equals, clear everything you have. And we have 2x to the fourth and minus x. And go to second and table. I will plug in negative 1. I will plug in 1/2, which is 0.5, and I will plug in 1. I will copy these values in the table. So for negative 1 is 3, for 1/2 is negative 0.375, and for 1 is 1. At this point, we will draw a conclusion. First of all, what type of point is this? 1/2, comma, negative 0.375. What type of point is it? Based on what you see here, and of course this is true, from 3 to this number it's decreasing, from this number to this number is increasing.
Minimum.
Very good. So this is a local minimum. Now we are really asked to find absolute. So I'm not graphing the function. I just want to show that the y value is here at 3. The next y value is here at negative 0.375, and this value is up here at 1. From all these 3 values, which one is the absolute maximum?
Three.
Yes. So this point is the absolute max. So negative 1 comma 3, absolute max. Is there an absolute min? But this is, one more time, it's not local. because it's at the end point of the interval. Is there an absolute minimum?
Yes. It's -0.
Yes, 1/2, comma, -0.375. This is an absolute min. Also local min. It's not at the end of the interval. So these were identified. What about this point? What about point 1, comma 1? What does this mean?
Is it intermediate?
Nothing. It's at the end point of the interval, and it's not the highest and it's not the lowest, and it cannot be local.